In this problem, we want to compute the derivative using the limit definition of the derivative. Okay, so for this general derivative, we're going to use the fact that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now we're going to apply that to this function right here to get that the derivative is equal to the limit as h approaches 0 of. F of x plus h means to replace each of those x's by x plus h in parentheses. As I do that, I'm also going to rewrite this negative exponent as a positive exponent by putting this in the denominator, and I'm going to write the rational exponent of 1/2 as a radical to make this easier to work with. Alright, so for f of x plus h, I'm going to plug in x plus h, and it will become 1 over the square root of, everything that's to the power of negative 1/2 will be under the radical, square root of 3 times x plus h plus 2. That's f of x plus h. Minus, parentheses, f of x, we're going to copy right here, is the original function, which is 1 over the square root of 3x plus 2. And that's all over h. Now when we distribute this negative, the 2's cancel nicely. So we'll go ahead and do that. Now we need to simplify this expression. It's a bit complex as is. We have a complex fraction. So I'm going to clear the complex fraction by multiplying by what I need to get rid of this denominator and this denominator over itself. So first I'm going to recopy what we have, except I'm going to go ahead and distribute the 3 and write it as square root of 3x plus 3h. Then we have minus 1 over the square root of 3x, and that's all over h. So I'm going to multiply this big fraction by the product of both of these denominators, radical 3x plus 3h times radical 3x, all over itself, so that I'm just multiplying by a fancy form of 1. Then we'll distribute over that numerator. So when I distribute this over this numerator, when I do this entire product of two radicals times this fraction here, the radical 3x plus 3h, those cancel. So we're just left with the radical 3x in that numerator. Minus, when I distribute all of that times this fraction, the radical 3x cancels with this radical 3x, so we're just left with that radical right there, minus the square root of 3x plus 3h. And in the denominator, we're going to leave it factored. Actually, there is nothing to distribute anyways because there's no plus, so it's just h times the square root of 3x plus 3h times the square root of 3x. Now, in order to simplify this expression, we're going to have to multiply by the conjugate of the numerator over itself. There's really nothing else we can do here. So I'm going to multiply by root 3x plus square root of 3x plus 3h over itself. Okay, to get, let's see, let's add in some parentheses here, here, and here. So in the numerator, we need to FOIL. So root 3x times root 3x becomes plain 3x. And then we have root 3x times that radical minus root 3x times the same radical. So the outside and inside terms cancel when we FOIL. And then we have minus root 3x plus 3h times root 3x plus 3h. So the radicals go away with minus 3x plus 3h. All over h times the square root of 3x plus 3h times the square root of 3x times all of that, which we'll leave in parentheses. We do not want to FOIL or expand the denominator because that would make it harder to cancel common factors here in a moment. Okay, then when we distribute that negative right here in the numerator, the 3x's cancel, And so we are then left with negative 3h in the numerator. And since the denominator is factored, that h will cancel with that h. So we are left with, in the numerator, a negative 3 over everything here in this denominator. And that is over the square root of 3x plus 3h times the square root of 3x, then times parentheses root 3x plus root 3x plus 3h. So then we can take the limit by plugging in 0 for all of the h's, which are there and there. Okay, so when we plug in 0 for those two h's, we get negative 3 over. This will be square root of 3x, because that term is 0. So we'll have square root of 3x times square root of 3x, which is plain 3x, times root 3x plus root 3x. That's going to be 2 times root 3x. And the 3's then cancel. So it looks like the derivative is equal to negative 1 over, I'll just reorder those terms there and write it as 2x times radical 3x.